Hi guys, I hope you enjoyed some sunshine this weekend. What we are going to do in this lesson, we're going to kind of go backwards just a little bit and just re-practice setting up differential equations and separating them. Okay, so if you see on the lesson on Blackboard for today, if you didn't watch the video going over the review worksheets on pages 31, 33, and 34, there's a video on there. Make sure you hand in your Chapter 5 Mega Multiple Choice. Do that through Google Classroom. And then there are two PDFs that are attached for today. One looks similar to this, and what we're going to do is we're just going to try to take words and write it in symbols. So that's all we're going to do. So for example, the first one says the rate of change of g with respect to t. So we know a rate of change is a derivative. A rate of change of g with respect to t is, and then anything that is proportional always has a proportionality constant, and they typically let the letter k be that. So k times the square of g. Now, it didn't say the square root, it said the square. And that's all we're going to do. We're just going to set them up so that you can get used to this. I suspect that there will be a free response that is a differential equation and is probably a word problem, so this is going to help you just with setting those up. We're going to jump around a little bit and then the rest will be homework, and the answers are all attached. Okay, number 4 is the next one. See if you can write down the rate of change of m with respect to t. So rate is a derivative with respect to t, is inversely proportional to the cube root of m. Anytime we have an inverse proportional problem, there's still a proportionality constant, but then what it is inversely proportional to is going to go in the denominator. Okay, so that's number 4. Let's jump to 6. The rate of growth of a population of zombies over time is proportional to the population of zombies. See if you can write that. So the rate of growth of a population of zombies over time is proportional to the population of zombies. Okay, so we're going to jump to number 7. Looks a little longer. Newton's law of heating states that the rate of heating an object is proportional to the temperature difference between the surrounding air and the object. There's a lot going on there. The rate of heating an object is proportional to the temperature difference between the surrounding air and the object. So they're talking about a cake that's put into an oven. The oven's preheated to 350 degrees. So the cake's put into this 350 degree oven. Let C be the temperature of the cake after T minutes. So the rate of change of the cake over time will be dC dt. It's proportional to the difference between the surrounding air is 350 degrees, minus the temperature of the cake. Okay, so that was a little bit tougher to weed through all those words. Let's do number 10, because this one will be in Newton's law of cooling. Newton's law of cooling states that the rate of cooling of an object is proportional to the temperature difference between the object and the surrounding air. So a hot cake from the oven is put on a table in a room that's 76 degrees. We're going to let C be the temperature of the cake after T minutes. See if you can write that differential equation. So hopefully you have dC dt equals K times the difference between the object, which is C, minus the room temperature. The next one, let's see, that I want to jump to is number 13. In a community of F farmers, the number X of farmers who own a certain combine changes with respect to time. So the number of farmers changes with respect to time. So hopefully we can write that derivative. And then changes at a rate that's jointly proportional. So that means we have two things that are multiplied together, two factors. Proportional to the number of farmers who own the combine and to the number of farmers who do not own the combine. This seems a little bit more complicated. So I know the rate that the number of farmers change with respect to time is dx dt, and it's going to be jointly proportional. So I know it's equal to k times, and I have two different things. So I have to figure out the number of farmers who own the combine. Well, it says up above, the number X of farmers who own the combine, so I know that's X, times the number of farmers who do not own the combine. Well, they didn't tell us that, but they tell us altogether there are F farmers. And so if X farmers own the combine, then the remaining F minus X do not own the combine. That was a little bit tricky. Okay, two more. So number 17 is going to be the next one. For the first 9 months of life, the average weight, W, in pounds of a certain breed of dog increases at a rate that's inversely proportional to the time in months. So the weight is going to change over time. So the rate of change of the weight, dw dt, is equal to k, that proportionality constant, but it's inversely proportional to the time in months. Now that, of course, there would be a domain, which would be those first nine months of life. And then the last one, number 19. An object that has been dropped falls at a velocity in feet per second that is proportional to the number of seconds after it has been dropped. Now we have to remember velocity is the rate of change of the distance s as a function of time. So I don't want to write dv dt, I want to write ds dt because ds dt is the velocity. So that's the velocity, and it's proportional to the number of seconds after that object has been dropped. So the velocity equals k times t. Okay, so part of the homework is to go back, and you'll see the answers are attached